All right, so for those of you who missed today's notes, I'm not going to explain this part because I already did in the notes, but you at least have it to kind of write it down. So here are the notes that we did. Okay, we talked about linearization and how it's the same exact thing as basically finding the equation of the tangent line, just a different way. Here's the example of linearization. Here's another example that you guys did on your own. And then we talked about the differentials, dy, and how that's f prime of x times dx, and dx is just basically the change in x. I had you guys watch a video on YouTube, which is now on iLearn if you wanted to refer back to it. And then we did some examples, finding dy. So finding just dy, which is different than finding dy dx. Just the only way it's different is that at the end you're going to multiply by dx on both sides so that dy is left by itself. Okay? And you're viewing dx as an independent variable and dy is dependent on dx. Alright, so let's look at this. This is where we left off. And we watched the video which explained what a plus dx is. So the idea is if you have a function at a and then and that is known, so this is the known point, and then you have this other point on x where f of a plus dx is unknown. Okay, so what we can do is we can approximate. So we have this tangent line that goes through this point right here, and the idea is the difference between the new point, a plus dx, and the point that we know is called change in f. And that is just going to be, change in f is change in y, right? So it's f of a plus dx minus f of a. And then once we do that, we need to figure out the change in the linearization, which basically at this point we know we can approximate where the, at this point we can approximate where the linearization is, but we cannot figure it out for this, so we are approximating what that point is, and that is what change in L is, aka dy. It's f prime of x times dx at a. Alright? So this is what the video was kind of explaining. So if you're having an issue understanding this one, just rewatch that video. So calculating the values of L are simple, so this is a practical way to estimate the change in f. Okay. So what do differentials do? Differentials approximate the change in the function by the change in the linearization. So we use the linearization to figure out the change in the function. We call df the differential of f, which is df equals f prime of x dx, which is the same as dy, okay? So when is the differential used? We use it to find change in y. Now change in y is the actual difference. So what we can do is by finding dy, this is the approximate difference. So for dx, dx is the same thing as saying change of x, a small quantity that we have. All right, so basically, let's cross this out. So the idea is a plus dx, so the new point, minus a is left with, you're left with dx. Alright, as we move away from a to a nearby point, a plus dx, we can describe the change in f in a variety of ways. And then we can calculate the errors between the actual change and the estimated change accordingly. We can figure out what our error is in percentage. So, the absolute change. So change in f, the formula for change in f is basically change in y, alright? So it's f of the second point on y minus f of the first point on y. Now df is equal to f prime of a times dx. We'll come back to these once we do a problem for them. So let's look at the first example. And let's find change in f. Let's find change in f. Sorry, can you guys give me just like 2 minutes? I'll be done. Consider the function f of x equals 2x squared plus 1 on 3, 4. See here they tell you what change in x is, it's 1, and they tell you what a is, and that's 3. So based on what we know, change in f is just basically going to be f of a plus dx minus f of a. They are the 2 points on the graph. Alright? So if I graph this function, from 3 to 4, and that's all I'm going to worry about is that domain. So at 3, we got 19. Let's call 19 right here. And at 4, we got 34. It's all the way up here. So given that the dx, which is the change in x, is 1, and given that this guy right here is a, find change in f and then find df. So all we have to do is just plug in numbers. So a is 3 plus dx, which is 1, minus f of 3. So this is f of 4 minus f of 3, which if you solve it, plug in f of 4 and plug in f of 3, you're going to end up with 33 minus 19, which is 14. So this is the actual. Now finding df, what we're going to do is find f prime of a times dx. So we're going to find the derivative of the function, which is 4x, right? 4x times dx. So now it's f prime of a and it's 4x, which basically is the same thing as saying a. But what is f prime of a, and what is a? It's 3. So it's 4 times 3 times dx, which is 12 times, what is dx? It's 1, and that's going to be 12. So this right here is the approximation. Alright? So you can see how we can figure out the error. Okay, the percent error, basically. Now, using the same function above, I want you guys to do this. Find the change of f if dx is 0.1 and x is 3. And if they're saying x is 3, that means a is 3. Find df, find the error, between the two numbers. And what do you notice between the values of df and change of f? As change of x equals dx changed in the value. Okay, let's make this part 1 because I have a little meeting that I need to get to. And then we are going to do this one example. I'm going to do that example in part 2 down here. Okay, and it's nothing different except we just have the formula for a sphere, for surface area. And I'm actually going to skip example 2 and example, oh, no. That will be it for section 4.5. We are not going to do this. We will do this, of course, in AP Calc, but not right now. So this is all I need you guys to do right here, student practice. And then we're going to go on to related rates. And in the related rates section, I'll be talking about this first part, what it means. We'll talk about the steps to solving related rates. And then I'm going to focus on 2 of the problems. So it shouldn't be a long video for part 2, but honestly, I'm probably not going to get it done till after school. So enjoy this one. See you guys tomorrow.